Child temporal spatial gait characteristics and variability during uphill and downhill walking, presented by Heath Griffith, Erin Hadley, Broderick Hodo, Cade Hood, and Meredith Thompson. Written by Stern K. and Gottschall J.
It is believed that the characteristics of a child's gait can be used to predict where that child is in his or her development. One specific characteristic to go along with that theory would be step width. Step width normally decreases as a child matures because that child gradually becomes better with standing stability and balance. The purpose of the study was to investigate the differences in walking strategies used by children in comparison to adults. 15-degree incline and decline hills were involved to further challenge the children and to bring out the differences in the results. The study believed that a better understanding of children's gait during hill walking would improve the testing of children's gait development.
We will now explain the methods of this study. Participants were chosen and separated into two groups. Their characteristics were compiled so that you can see the mean values here in this slide. The first group consisted of 30 children that were deemed as healthy. It is important to note that all children participating were attendees of the Pennsylvania State University daycare program and provided written consent from a parent or guardian. The second group consisted of 30 young adults that were deemed as healthy as well. You can see the mean values of their characteristics below. Each group completed 5 trials of level walking, uphill walking, and downhill walking. The children's group was monitored by 3 researchers for validity, and any trials that involved an incomplete stride length, shuffling, or jumping, and even running were eliminated. The adults group was assessed and recorded with a 6-camera system, a passive marker, and 3D photogrammetry, whereas the children's group was assessed and recorded with the Gait Right pathway using a custom-made MATLAB program. Both groups were able to choose their own individual velocity, but it is important to note that there were some differences in the length of the level pathway as well as the length of the hill. Stride length for the children's group was defined as toe off to toe off. However, for the adult group, it was defined as left toe off to left toe off. Data was gathered and calculated for each group. It included stride length, stride speed, width, and stance time, or percentage stance time, for the children's group. Each of these was recorded with only full stride lengths. Data was compared between the two groups. The Newman-Kuhl's-Hawk test was performed for variability, mean values, and percentage difference in level to hill strides. Alpha level was set for statistical significance at less than or equal to 0.05.
These are the results from our study. There was only one significant difference between the two groups, and that was a greater reduction in stance time percent during downhill walking for the child group compared to the adult group. There were several significant differences within the age groups. For the child group, step width and percent stance time was greater during uphill walking compared to downhill walking. Compared to level walking, downhill walking had significantly greater variability in speed, stride length, and percent stance time, and no significant differences in step width variability. Compared to level walking, uphill walking had no significant differences in variability for speed, stride length, step width, or percent stance time. For the adult group, speed was less during uphill walking as compared with level walking. Stride length was less during downhill walking as compared with level walking, and stance time percent was greater during uphill walking as compared with level walking.
Based on this study, researchers found that children walk slower than adults on a level surface, uphill as well as downhill. This can be attributed to a decreased stride length, step width, and stance time. Temporal spatial gait variability is greater in children in comparison amongst the children's group with hill walking, and then compared to adults on a level surface, uphill and downhill. Children walk slower and take narrower steps than adults as well. In regards to temporal spatial gait, researchers found that after the age of 4, there was an increase in walking speed, stride length, and step width. There were fewer significant differences for level to hill walking. In adults, they found a significant difference for slower uphill and downhill. Compared to children, they had a slower uphill but a faster downhill. Step width changes is greater in children compared to the adult group in level, uphill, and downhill walking. But when comparing amongst the children's group, they saw greater variation in downhill walking. Stance time, stride length, and stride speed are more variable in children compared to adults with level, uphill, and downhill walking. And when comparing amongst the children's group, they saw a greater variation in downhill walking, and they think this could lead to an increased risk for falls. The limitations of this study were the use of the independent stride variability with trial-to-trial comparisons versus the continuous long period walking. How this worked was they did 5 trials of each surface, and after each trial they decreased the walking duration to help decrease fatigue. With decreasing the walking duration, they also decreased the amount of steps that were analyzed. This made it less accurate compared to the ones that had one continuous long walking period. In conclusion, previous research has shown that gait variability and temporal spatial gait parameters is similar to adults by the age of 16 to 14 years old. Hill walking can be used to encourage a more stable and a safer gait in children with gait training, and further research is needed to assess hill walking with individuals with abnormal gait or neurological disorders in a wider variety of children age groups compared to adults.
This information could prove very useful in treatment of underdeveloping children. Level surface walking could be used as a screening tool to identify underdeveloping children. This is due to gait variables in children 6 to 14 years old resembling adult gait variables. Gait training children on hills can improve stability and improve their response to a change in surface type. Both overall muscle strength and walking experience contribute to a child's walking balance. Thus, increasing overall strength decreases their risk of falls. Increasing practice time on different terrains increases gait stability on all different types of terrain.